Have you ever wondered who designs the clothing that keeps soldiers alive and mobile in extreme weather? Well, Military Times senior editor Sarah Sicardini recently visited the labs at the United States Army Research Institute of Environmental Medicine in Natick, Massachusetts. There, we got to see the science behind the uniforms.
So where are we today?
Okay, we're at the United States Army Research Institute of Environmental Medicine, or USAREM, in Natick, Massachusetts, and we're currently in a thermal mannequin laboratory.
Great, and can you explain what that is?
Okay, so this is a thermal mannequin. Traditionally, they used to be copper mannequins, so some people still use that terminology, but now it's a fiberglass epoxy resin with embedded heaters. So this is basically a tool we use to measure clothing data properties.
And why is he sweating right now?
Okay, so that's one of the tests that we do. So we do two tests. We do an insulation test, and then we do a vapor permeability test. So part of the vapor permeability test is that make sure that the whole skin is 100% saturated. So that's where the sweating function comes in. What
are some of the projects that you're working on right now?
Okay, so we've been dealing with a lot of cold weather clothing. New prototypes for cold weather clothing. There's always different layers and different combinations of layers that we can test. Additionally, we've been working with wet clothing. So we want to characterize the effects of wet clothing on heat loss.
So is this your only mannequin?
No, it's not. So actually we have 4 similar mannequins to this, and then we also have separate mannequins for the head, the hand, and the foot, and those provide us more resolution, and we can look at smaller zones. So this mannequin has 20 separate zones. So the head is basically one zone, the hand is one zone, and the foot is one zone. So with our body part mannequins, we can look at smaller areas of the body. So for the hand mannequin, for example, we can just look at a single finger, which is beneficial for gloves. And same thing with the foot, we can just look at a toe section, which gives us more information than just looking at the whole foot. We have another lab upstairs with a couple different chambers. One of my colleagues is working on some cooling systems. So for soldiers that are wearing very occlusive uniforms, chem bio uniforms in hot environments, they need to be cooled, or otherwise they're going to end up with heat strokes. So we're evaluating cooling systems to keep soldiers cool. And on the other hand, we have interest in testing heated garments. So on the other side of when you're in cold environments, you might need additional help to keep the soldier warm. So we need to evaluate heated clothing and see what works best for the soldiers.
So tell me a little bit about how regulating body temperature sort of translates into product out on the field.
So basically, we look at standardized testing. So I'm sure you'll talk to some physiologists while you're here, and they can explain how the body temperature regulates. But basically, we're looking at properties of clothing and how that relates to regulating the human body temperature.
The Thermal Lab works with the Coast Guard, and both use an interesting model to estimate the survival of a person going overboard. Different inputs can be changed, such as water temperature and clothing, and it helps estimate how long someone will stay alive after falling into the water.
We created this graph where there is some degree of uncertainty about what human inputs you use, what clothing they use, how turbulent the water is, we're basically going off of measurements that may not be precisely accurate of where the person overboard is. So there could be some discrepancy in water temperature and air temperature as well. So this gives you kind of a graph of possible survival times. So we're going to say at 9.8 hours in the water, according to these conditions, they're almost 100% still going to be alive. And then at about 19.8 hours, we're going to say they're most likely, even considering all variables, best case scenario, most likely they probably have not survived.